Hello students, and welcome back to Chemistry A. This is Ms. Sleight, and today we're going to be talking about chemical and physical changes, as well as the law of conservation of mass. First off, a physical change in matter is one that alters only the appearance of the substance. The properties of that substance are unchanged in a physical change. For example, tearing something, bending it, change in shape, those are all physical changes. So if I take this piece of paper and I tear it into lots of little tiny pieces, it doesn't matter how many pieces I tear the paper into, it's still paper. It still has all the properties of paper. It's white, it's flexible, you write on it. None of its properties have been changed. It's still paper. That's why this is a physical change. The other type of change in matter is a chemical change, which does just the opposite of a physical change. A chemical change does indeed alter the identity of a substance, and a new substance or substances with new properties will be formed at the end of a chemical change. Some examples are burning things. If you see heat or light produced, if a gas is produced, if you see any signs of a chemical reaction, that means that a chemical change is taking place. So for example, if I take this piece of paper and I light it on fire, don't do this at home, we can see right before our eyes the properties of the paper being altered. It is giving off a little bit of smoke. It's definitely giving off heat and light. The color is changing. Texture is changing. And it's becoming ash. And we can see the parts of it that have been completely burned look nothing like paper anymore. The properties are totally different. That tells us a chemical change has taken place. So these changes in matter bring us to what's called the law of conservation of mass, which is probably the most important principle for basic chemistry. And the law of conservation of mass states that when a system changes, chemical or physical, the total mass of the system will remain the same unless particles enter or leave that system. So what this means is that anytime you have a chemical reaction, even though some new substance has been created, the mass should stay the same. The mass of your reactants, what you start with, needs to be equal to the mass of your products, what you end with.
Alrighty, folks, now let's look at some examples for law of conservation of mass. Our first example says, in an experiment, 10 grams of red mercury 2 oxide powder is placed in an open flask and heated until it is converted to liquid mercury and oxygen gas. The liquid mercury has a mass of 9.26 grams. What is the mass of oxygen formed in the reaction? So there's a lot going on here. So what I like to do with big wordy problems is I like to go through and underline the important information that they tell us and circle what it is they want us to find. So 10 grams of mercury 2 oxide converted to liquid mercury and oxygen gas. And it says liquid mercury has a mass of 9.26 grams. What is the mass of oxygen? So it's helpful kind of to think about this in terms of like before and after. So initially we've got our mercury 2 oxide, and they tell us that it has a mass of 10.00 grams. When this is heated, it becomes liquid mercury, and oxygen gas. And they tell us that the mass of the liquid mercury is 9.26 grams. And the mass of the oxygen is what we want to find. Well, according to the law of conservation of mass, the mass of your reactants, whatever you start with in a chemical reaction, must be equal to the total mass of your products. So the mass of the liquid mercury and the mass of the oxygen gas have to both add up to 10 grams. So if I want to figure out just the mass of oxygen, I can just subtract. So I'd go 10.00 grams minus 9.26 grams, and I get an answer of 0.74 grams of oxygen. Let's look at another example of this kind of problem. Another example says, in the complete reaction of 22.99, that must be grams of sodium with 35.45 grams of chlorine, what mass of sodium chloride is formed? So this is the important information they're giving us, mass and elements. What mass of sodium chloride is formed? That's what they want us to find. So they're telling us that sodium is reacting with chlorine, and at the end we get sodium chloride. Well, the mass of just the sodium was 22.99 grams. The mass of just the chlorine was 35.45 grams. And we want to find the mass of the sodium chloride. Well, again, if the mass of your reactants has to equal the mass of your products, all I need to do is add these two masses together. And when we add these together, we get an answer of 58.44 grams of sodium chloride. And that's all you have to do for law of conservation of mass type problems. Figure out what's reacting together, what's being formed as a product, and what items do you have the masses for. If you can do that, you'll be able to figure out what the missing mass is. That's all we have for today, so I hope you have a great rest of your day.